This is Ishwar. My topic is closure property. Property states that when a set of numbers is closed under any arithmetic operation such as addition, subtraction, multiplication, and division, and is performed on any two numbers of the set with the answer being another number from the set itself. This property is applicable for real numbers, whole numbers, integers, and rational numbers. Let us learn more about closure property regarding each form of numbers and solve a few examples. What is closure property? Closure property can be defined as the closure of a set of numbers by using arithmetic operations and is completed by these operations. In other words, when the operation is performed on any two numbers from a set and the result obtained will be the number from the set itself is considered to be closed. A set either has or lacks closure depending on the given operation. The closure property is applicable for addition and multiplication for most of the forms of numbers. However, for a few subtraction and division, as the result might not be the same form of the number. For example, 4 plus 5 equal to 9. Here, all the numbers are natural numbers. Let us see the closure property of each arithmetic operation in brief. Closure property of addition. Closure property of addition states that when any two real numbers are added, the result will be a real number also. For example, 2 plus 5 equal to 7, where all the three numbers are real numbers. The formula is a plus b equal to r, where a comma b and r are real numbers. Let us see this property for all real numbers. Natural number a plus b equal to n. A comma b and n equal to natural numbers. Whole numbers a plus b equal to w. A comma b and w whole numbers. Integers a comma b equal to c. A comma b and c are integers. Rational numbers a plus b equal to q. A comma b and q equal to rational numbers. Closure property of multiplication. Closure property of multiplication states that if any two real numbers a and b are multiplied, the product will be a real number as well. For example, 5 into 2 equal to 10. This property is applicable for natural numbers, whole numbers, integers, and rational numbers. Let us see this property for all real numbers. Natural numbers. A cross B equal to n. A comma B and n are natural numbers, whole numbers. A into B equal to W. A comma B and W are whole numbers. Integers. A into B equal to C. A comma B and C are integers. Rational numbers. A into B equal to Q. A comma B and Q are rational numbers. Closure property of subtraction. Closure property of subtraction states that if any two real numbers A comma B are subtracted from each other, the difference or result will be a real number as well. For example, 9 minus 4 equal to 5. This property is applicable only for integers and rational numbers. Integers. A minus B equal to C. A comma B and C equal to integers. Rational numbers. A minus B equal to Q. A comma B and Q equal to rational numbers. Closure property formula. Closure property formulas use all four operations where each of them results in the respective numbers. If two real numbers A and B are given, then the closure property of numbers is given as A plus B equal to or A minus B not equal to or A cross B equal to or A divided B by B not equal to or. Note: closure property for subtraction is applicable only for integers and rational numbers. Closure property under division. The set of real numbers includes natural, whole, integers, and rational numbers is not closed under division. Division by zero is the only case where closure property under division fails for real numbers. If we ignore this special case, division by zero, we can say that real numbers are closed under division. Closure property of whole numbers under division. Division of whole numbers does not follow the closure property since the quotient of the any two whole numbers A and B may or may not be a whole number. Example: 18 divided by 4, 9 by 2, not a whole number. 22 divided by 1, a whole number. Closure property examples. From the following, determine which option is available for closure property of integer. 10 plus 5 equal to 5. 3 minus 9 equal to minus 6. 7 into 2 equal to 14. 3 divided by 4, that equal to 0.72. According to the closure property of integers, addition, multiplication, and subtraction is applicable where A plus B equal to C and A minus B equal to C, where A comma B comma C are integers. Hence, the four options A, B, C are applicable and option D is not, since 0.75 is not an integer. Example 2. Help Josie check if 17 divided by 2 comes under closure property solution. Let us first divide equation where 17 and 2 are natural numbers. 17 divided by 2, that equal to 8.5. 8.5 is not a natural number. Therefore, closure property is not applicable here. For this equation comes under the closure property 1 by 3 minus 1 by 4. According to the closure property, if any two rational numbers are separated from each other, the difference will also be rational number. 1 by 3 minus 1 by 4, that equals to 1 by 12. 1 by 12 is a rational number. Therefore, closure property is applicable. It's of closure property. Some of the important examples of closure property include the following. The transitive closure of a set is an example of closure property is in set theory. The transitive closure of binary relation is an example of closure property in set theory. Thank you.